Okay, so at the start of filming this video, it is about 3:48 a.m. I'm probably only going to film until 5 a.m. at the latest. Film, edit, upload, combine them into one video. So probably around 5 a.m. I'm going to stop. I'm hoping to get to problem 15 and then 1 through 10 of the AMC 12. I've been up almost 24 hours now and I only got 6 hours sleep last night. So I can't film all of it and I'm going to sleep and then I've got to teach classes, and so I don't know when you'll get more content after that, just so you know. The sequence 1XYZ is arithmetic. The sequence 1PQZ is geometric. Both sequences are strictly increasing. There's no double, like this could not be 1, and contain only integers. And Z is as small as possible. What is the value of? We don't care about that part yet. You just want to make sure you achieve this. This is a problem you can pick up a lot of time on. You can save time, basically. You might have spent more time earlier coming up with your strategies. This one's pretty straightforward. You just do what an arithmetic sequence is. So it's really going to be 1 plus a common difference, 1 plus 2 common differences, and 1 plus 3 common differences. Then go over to the other one, 1PQZ, and write 1. R, which is the common ratio, 1 times R is just R squared, and R cubed. So now I'm going to need R cubed to equal 1 plus 3D because they're both the value of Z. So at this point, try picking out random things and cubing. It's like a Diophantine at this time. So you're going to say, well, if R is like 2, it can only be integers, so that would give you 8. You're looking for a cube that is 1 more than a multiple of 3. That's what you're thinking of. If you want to be fancy, you can say it's congruent to 1 mod 3 and you'll sound super smart and you give yourself a pat on the back. The rest of us might just want to call it 1 more than a multiple of 3 and not make our brain any more taxed than it needs to be. So 8, unfortunately, is 1 more than 7. 7 not being a multiple of 3, 8's not going to work. 27 is a multiple of 3. What about 64? 64 is 63 plus 1. Perfect. So it's going to be 64. That's this number here. And if I want, this will become probably 4 since R was 4. And this will become 16. 1, 4, 16, 64. So that times 4 times 4 times 4. Meanwhile, over here, if that's 63, then 3D, this would be equal to 63 because they both had plus 1. So D is 21. So you're going to add 1, add 21, add 21, add 21. And that's it. You've got all the values. What is the value of all of those plus the X and the Y? So if you add 21, if you just add 3 plus 6D, that's the value of X, Y, and Z added together. D being 21, you have 6 times 21 is 126, plus 3 is 129, and then you add 20 more for these two. Why don't we add that one? Because we've already got it in the 1 plus 3D calculation. So we have 129 plus 20, 4 and 16, which is P and Q, and that's going to give you 149. Let's get to problem 12. On to problem 12 from the 2025 10A. Carlos uses, I do feel like this problem wasn't overly difficult, but you had to take time to second guess your conclusions and make sure you're not leaving anything out, and did you really understand it right with that casework, and so on. So it might have taken you a bit of time. I'm not going to be unimpressed if you spent 4 to 5 minutes being sure that you had this one right. I don't think that's a terrible solve time. Carlos uses a 4-digit passcode to unlock his computer. In his passcode, exactly 1 digit is even. So only 1 even. Okay. And exactly 1, which is possibly different digit, is prime. That tells you they're talking about 2, of course, because 2's prime and it's even. So I already want to do casework. How do you know when to do casework, people ask me? It's really simple. Can you think of another way? Great, then you're doing casework. That's really it. If you have another way, like complementary or whatever, in which you still might be doing casework, casework is your safety net for counting and probability. So in this case, you just go, I can't think of another way, I'm just going to do casework, okay? It lets you separate the situations, which is an important part of why we use casework. So I'm going to say case 1 is when my even equals 2 equals my prime. So it's the same number. So if I do that, my other evens are 4, 6, and 8 because no digit is 0. So 4, 6, and 8. My odds that are not prime are only, see, you got 3, 5, and 7 are all prime. It's only 1 or 9 that you can use. 1's not prime, nor is it composite. So at this point, if I use 2, I could actually not have any more evens because only one number is even and I used it for also my prime. That means everything else needs to be a 1 or a 9, but keep in mind it's a 4-digit passcode. So you're going to have to do arrangements of these as well. So I might do something like, let's go 2 with A, A, B. Let's go 2 with A, A, A. And that's kind of it. It's those two cases, right? Either they're all three going to be the same numbers, something like 2, 1, 1, 1, which will have 4 ways. Or it's going to be two 1s and a 9. Okay, so how many, there's 4 ways for this one, but did A have to be 1? No, A could have been 9, and that's why you're going to do times 2 to get 8 ways for that case. Now, if I do this one, I'm going to treat it like how many words you can spell, where you have like 2 A's, a B, and a C. And it's going to be 4 factorial over 2 factorial, and that's going to be 4 factorial over 2 factorial. But keep in mind as well, we have to double that because there's also the 991 case. So if I have 2 9s and a 1 instead, that means we're going to cancel here. You're going to have 24 ways that you can do this. Altogether, case 1 is going to have 32 ways. Okay, so now case 2, my even does not equal 2. Therefore, I have to pick a different even. I'm going to have 3 choices. This is, you kind of want to tell yourself what you're doing. That is your even. Like, what is your even? 4, 6, or 8? 3 choices. Next, you're going to multiply with your choice for your prime. Don't forget what primes we have left. We can't use 2. We're going to have to use 3, 5, or 7. I'm going to again have 3 choices. And this is, what is my prime? So now you're like, okay, so I've got that, but now what? Let's just give myself something to latch onto. Let's just say that I chose 4 and then I had 3. Now what? Well, everything else cannot be even and cannot be prime. It can only be 1s or 9s. So again, I can either go A, A, or I can go 4, 3, A, B. And I just got to thinking too, we also need to do, yeah, that one had 4 ways. Okay, we got this right. I wanted to make sure we did the arrangements for it properly. Nothing, no issues like that. So now if I have 4, 3, say again that A and A are the same number, I would have, for this case right here alone, I would have 3 times 3, this same 3 times 3, and then times 2 choices for whether they're 9s or 1s. And then once I have that, how many arrangements does this have for a particular case? It's again going to be 4 factorial over 2 factorial, which is 24 over 2, which is 12. So this is 3 times 3 times 2 times 12. What about this one? Well, it would obviously have to be 4, 3, 1, 9. There's no choice of 1 and 9. It has to be those two. They're the only numbers remaining that are not even and not prime. Again, you're telling yourself this story in your head to convince yourself that you're not leaving anything out. And if you're not telling yourself these things, you might have made a mistake, or you just are very good at not making mistakes. But I don't like to risk it. I like to reinforce constantly all of my thoughts and conclusions that I'm justifying why I'm still right with that conclusion. Okay, so then what? This then becomes 3 times 3 times the arrangements of this, which is simply 4 factorial, or 24. And so as you can see, these are identical. So it's like having this doubled. So I've got 24 times 2 is 48. I've got 9 times 48 is my total case 2. So how might I do this? I don't know. It's whatever you want to do. 360 and 72 is 432. If I take 432 and I add 32, we'll find ourselves at 464. We should pause a moment and ask, am I sure I didn't leave anything out? There's no other way. Either my even number is 2 and therefore plays the role of the prime, or it's not 2 and a different number plays the role of the prime, which will be one of the odds here. And I do have to choose only from 4, 6, and 8. Okay, we checked it all. Very satisfied. This is going to be the answer. Let's get to problem 13. Continuing with 10A problem 13, the last problem of 12A's rapid fire set for 1 through 5. In the figure below, the outside square, this one, contains infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side length of a square to the side length of the next inner square is k, where k is a number between 0 and 1. What that would mean, think about what that means. It means that we're going inside, that this side length here is k times whatever this is. And this one is k squared times whatever this is. And this one is k cubed, and so on. Okay, the spaces between squares are alternately shaded as shown in the figure, which is not necessarily drawn to scale. I didn't put any more than this because it's too much space in there, but you had the picture on there, you kind of remember what it was. The area of the shaded portion of the figure is 64% of the area of the original square. What is k? I thought, well, I don't know how to start, but 64% plays really well with 100. So maybe I'll just call this length 10 and 10. But we don't know they're 10. In fact, it doesn't matter what you put, it's still going to work out. So I'm going to put 10 because it gave me comfort. Maybe it'll be easier to do if I do that. So what do we do next? Well, this outer ring, if you will, of the square ring is going to be 10 squared minus this part right here is going to be 10k. So it's going to be 10 squared minus 10k quantity squared, right? Because I'm multiplying 10 by the scale factor k, which makes it smaller. And I'm going to take that and I'm going to add the next ring. This nut right here, this side right here is going to be 10k squared. So now we're going to do 10k squared squared, because it's an entire square's area, minus this one right here, the inner square that's white, is going to be 10k cubed. And you have to square that. So it's minus 10k cubed, and I'm squaring that. And so my hope was that we can find a pattern in what's happening, probably an infinite geometric sequence, because infinitely many, that's what you would expect. And this will go dot, 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 and it's going to equal, this is the total area of the shaded region, it's going to equal 64 over 100, 64% of the whole thing. And it wants us to find k. So let's go ahead and clean this up a little bit. It's going to be 100 minus 100k squared, and then plus 10 squared is 100, k to the fourth, and then minus 100k k to the 6th, and you can see now that we're going to factor out 100. And we're going to have 1 minus k squared plus k to the 4th minus k to the 6th plus, and there you can see your infinite series as we anticipated. So what I want to do now is go ahead and I guess you would probably simplify this. I needed some space, so I'm going to have to erase this right here, unfortunately. You'll have to go back in the video to get that because there's just not enough space to solve on my whiteboard with what we have written. So I'm going to have then 100. Well, actually, this was only equal to 64, not 64 over 100, because our whole thing was 100, so the shaded region's area was only 64, not 64 over 100. In fact, this 100 will divide over there to give us that. So we're going to have 100 times, what is the sum of an infinite geo? It's a sub 1 over 1 minus r. So our a sub 1 is 1, and our r, what are we multiplying by? 1 times negative k squared. You can always check by taking this term and dividing by that, taking this term and dividing by that. If you get the same thing consistently, it's geometric, and that same thing is negative k squared when you simplify. So that's going to be what we put here, but make sure you put negative k squared, like that. And this is going to equal 64. I'm going to go ahead and divide by, 4 right now. I'll put this underneath, and I'm going to write 25, and here I'm going to write 16. So I divided this by 4, and I divided that by 4. Now I'm going to have 1 over 1 plus k squared. The negative is not being squared. It's outside. It does not get squared by that. Is equal to 16 over 25. We cross multiply 25 equals 16 plus 16k squared. We subtract, we get 9. We divide by 16, and k will equal 3 over 4, which is answer choice D. Let's get down to the next problem.